In this video, I will explain the electromagnetic waves. Electromagnetic waves are waves made up of oscillating electric and magnetic fields. Electromagnetic, electric, and magnetic. So they are made up of oscillating electric and magnetic fields that travel through space. They are produced by accelerating or vibrating charged particles that propagate through space. So they are produced by accelerating or vibrating charged particles that propagate through space. The electric and magnetic field are perpendicular to each other. They are perpendicular to each other and also to the direction of propagation of the wave. So we have something like this. If this is the direction of the electric field, this is the direction of the magnetic field. This is the direction of the propagation velocity. So both the electric fields and magnetic fields are perpendicular to each other, and they are also perpendicular to the direction of propagation of the wave. Characteristics of electromagnetic waves. 1. They are transverse waves. All electromagnetic waves are transverse waves, meaning the direction of propagation of the wave is perpendicular to the direction of vibrations of the wave. So the direction of vibration of, in this case, it's the direction of vibration of the electric and magnetic field. 2. They do not require a medium to propagate. Electromagnetic waves don't require a medium to propagate, meaning they can travel through a vacuum or empty space. Theory. They all travel at the speed of light. The value of the speed of light is 3 times 10 to the power 8 meter per second. So all electromagnetic wave travels at the speed of light in vacuum, the value of which is 3 times 10 to the power 8 meter per second. Or they show wave properties like reflection, refraction, diffraction, and interference. So they show wave properties like reflection, refraction, diffraction, and interference. In addition to this, they also exhibit polarization because they are transverse waves. That's the typical characteristics of transverse wave, polarization. So electromagnetic waves, because they are transverse waves, they also exhibit polarization. So these are the properties of electromagnetic waves. They are transverse waves. They do not require a medium to propagate, so they can travel through a vacuum or empty space. They all travel at the speed of light in vacuum, the value of which is 3 times 10 to the power 8 meter per second. And they show wave properties like reflection, refraction, diffraction, and interference. And also, since they are transverse waves, they exhibit polarization. The electromagnetic spectrum. This is the whole range of the electromagnetic waves. This is gamma rays. This is X rays. This is ultraviolet. This is visible light. This is infrared, microwaves, radio waves. So this is the electromagnetic spectrum, which is the whole range of the electromagnetic waves. So we have GXU, VIMR, gamma rays, X-ray, ultraviolet, visible light, infrared, microwaves, and radio waves. This order is the decreasing order of frequency or increasing order of wavelength. Decreasing order of frequency or increasing order of wavelength. The meaning of this is that gamma rays have the highest frequency and the lowest wavelength, while radio waves have the lowest frequency and the highest wavelength. So the higher the frequency, the lower the wavelength. Decreasing order of frequency or increasing order of wavelength. Gamma rays the highest frequency with the lowest wavelength. Radio waves the lowest frequency with the highest wavelength. That's the electromagnetic spectrum. GXU, VIMR, gamma rays, X-rays, ultraviolet, visible light, infrared, microwaves, and radio waves. The electromagnetic wave equation. There is an important formula connecting the speed of the wave, the frequency of the wave, and the wavelength. And the formula is C equals to F lambda. C is the speed of the wave, which is equal to 3 times 10 raised to power 8 meter per second. So that's the speed of the wave, which is equal to the speed of light in a vacuum. F is the frequency. The unit is hertz. While lambda is the wavelength, and the unit is in meter. So that's the formula. The formula is very important, so you have to know it. Now, if you make F the subject of the formula, F equals to C over lambda. So you notice that F is inversely proportional to lambda, which is the wavelength. C is constant. So F, the meaning of this is that the higher the frequency, the higher the wavelength, the lower the frequency. And the lower the wavelength, the higher the frequency. So they are inversely proportional. High wavelength means low frequency, and wavelength means high frequency. That's for the electromagnetic wave equation. Here is a practice question. A beam of light has a wavelength of 500 nanometer. Calculate its frequency. We are given the speed of light 3 times 10 to the power 8 meter per second. So let us do it. We are given the wavelength to be equal to 500 nanometer. We have to convert this nanometer to meter, since 1 nanometer is equal to 1 times 10 to the power minus 9 meter. So 500 nanometer will be equal to 500 times this divided by this. 500 times 1 times 10 to the power minus 9 over 1 meter. And that is equal to 5 times 10 to the power minus 7 meter. So that's the wavelength in meter. So we can now use C equals to F lambda. F equals to C over lambda. F equals to 3 times 10 to the power 8 over 5 times 10 to the power minus 7. That is equal to 6 times 10 to the power 14 hertz. So that's the frequency. 6 times 10 to the power 14 hertz. Uses of electromagnetic waves. G, X, U, V, I, M, R. Gamma ray, X-ray, ultraviolet, visible, infrared, microwaves, and radio waves. Starting with gamma ray, it is used in cancer treatment. It can destroy some cancerous cells, though you have to be very careful so it won't affect the normal tissue. For X-ray, it is used in medical imaging. For bone and teeth. For ultraviolet, it is used to sterilize medical equipment. For visible light, which is the light you can see, it is used for illumination. So this allows you to see. This is the visible part of the spectrum. For infrared, it is used in remote control for device. And also infrared cameras. For microwaves, it is used to cook food, cooking. In a microwave oven. While for radio waves, it is used in broadcasting. And TV signals. So those are the uses of the electromagnetic waves. Gamma rays is used for cancer treatment. X-ray is used for medical imaging. Ultraviolet is used to sterilize medical equipment, while the visible part of the spectrum is used for illumination. The infrared is used for remote controls. And also in infrared cameras. For microwaves, it is used for cooking of food in microwave ovens, while for radio waves, it's used in broadcasting radio and TV signal. So that's all about electromagnetic waves. And the end of this video. Thanks for watching.